Hi class, in this video I'm going to go through just the tail end of sketching lines, and then I wanted to go through the next section, which was finding the equation of a line. Alright, so this is on page 20 I believe. So look, we're looking at some special lines. Before we do, let's go through and remember when we have a line, it can be in the equation y equals mx plus c, where the m is the gradient, the coefficient of x, and this c, the constant in this form, is the y-intercept. Now, if I can remember that when going through these, so y equals 2, well, that's the same as saying y equals 0x plus c. Notice that would be the y-intercept. And if I wrote it out like this, then the gradient, the coefficient of x, is 0, which means, what does that mean? It means the gradient is 0. So what is a 0 gradient? Well, if I was riding a bike with a 0 gradient, I'm not going uphill or downhill, it would have a shape like that. It would just go across. So if I'm sketching this at this, all the values of y, if we go x and y, R2. Now, of course, you can always rote learn and go, okay, if I have y equals 2, then that goes through, that is a horizontal line. Now, when it's x equals minus 3, though, well, x equals minus 3, so we can't really apply it over here because we don't have like a y equals mx plus c. But what we could do is we could just simply say that, well, all the values of x are minus 3. So, for example, there's x equals minus 3. And that is going to be, if I was to draw that, all of those points. If I was to pick over here, we could say sort of minus 3, 3, all of these points. Let's say if I went down here, minus 3, I don't know, let's say minus 10. All of these points have x equals minus 3 in common. So x equals minus 3, or x is going to be a vertical line. We could, however, for C, look at this. So, well, first of all, what is the plus c? Well, the plus c is 0, which means that the y-intercept is 0. Y-intercept 0 means that it goes through the axis. But what does the gradient tell us? Well, the gradient m is equal to minus a half x. So the m part is minus a half, which means that it's going to have a negative gradient. Now, if I go across in sort of ones, let's say that's 1, here we go. Well, what does that mean? Well, let's look at gradient and like rise over run. What that means is that it sort of goes across 1. Sorry, it goes across 2. And because of this, negative actually goes down 1. And it goes, we know that it goes through the origin because the y-intercept is 0 because of this guy over here. So if you can see there, it goes across 2, down 1. Let's sort of say that would be representative of that. And it's just about sort of getting that right. So if I was to say 1, 2, which doesn't have to be an exact science for now, but clearly that's not going to be as steep. That's going to look something like this. These are sort of 3 unique lines. This one goes through the origin, and we've got a vertical and a horizontal line. Okay, so hopefully that you can practice those in addition to our other ones where we have, a y-intercept, which is not 0, it doesn't go through the origin, it's not one of those unique lines. My suggestion is, as you go through this, pause it. If you have your notes with me, please make sure you fill in your notes. If you don't, I will email you the notes, and my suggestion is if you have a printer, to print those out. And if you don't have your notes or a printer, well, you'll need to do these in your exercise books as we go. Okay, Now let's go, we're on page 21 of our notes now. Let's have a look at a worded problem. Now look, again, I'm going to talk about y equals mx plus c, but we don't always have y's. This, though, is sort of like this variable depends on sort of x. As x changes, we're going to y, but this time we're looking at picking apples, and Sam gets paid $10 plus $2 per kilogram of apples. So if she earns C dollars, so now we're looking at C and N. So C depends on N. Like you can almost see that this is this Y is like the dependent variable, and it depends on X, which is the independent variable. You'll see this in science as well when you do that. You do experiments and you'll test the relationship between our independent variable and a dependent variable. So now look, it says here that we're sketching between, n is 0 to 10. So let's have a look. It says write a rule. Well, we don't really want y's. We want the cost, or she gets paid, C, Sam earns C, and C is going to depend on how many kilograms of apples she picks. Plus she gets $10 plus $2 per kilogram. So notice there that she gets plus $10 no matter what. Doesn't pick any apples, then she still gets $10. So $2 per kilogram. So I guess in this case we could let N, or we've been told that N is the number of kilograms of apples picked. So this is just sort of like your worded sort of problem, but yeah, once we sort of get the concept of y equals mx plus c, let's have a look. Y is now c, x, our variable, is another variable, and c is going to depend on how many kilograms are picked. So, and it says here it gets $2 per kilogram. So if I was to multiply the number of kilograms of apples picked by 2 and add 10, that's my linear equation. Okay, so there you go. We've just done our linear equation. Now it says to sketch. So if I was to sketch this, it's exactly the same, but this time, of course, we don't need to sketch a whole graph because you can't pick less than 0. We're going to label it N, and C is going to depend on. Clearly, she's going to get, though, she picked no. If we have a look, what is this? This is like y equals mx plus c, the constant. This is the y-intercept. Well, in this case, it's not the y-intercept, it's the c-intercept, isn't it? So c is 10. And you can see there that the gradient is 2, y equals mx plus c, coefficient of x, in this case, the coefficient of n. So in other words, as we go up by 1, if I go 1, 2, 3, 4, if you think about it, now we could go ahead and sketch this. If I go across 1 and pick 1 kilogram of apples, then I'm going to earn, Sam's going to earn $12. Its gradient is 2. And it's going to look something like this. We could sort of go up in 2s by the gradient. Okay, and we could just fill that in, and of course we wouldn't extend this line out because, well, you certainly can't have negative numbers of kilograms of apples. That just doesn't make much sense, is it? So we've just got a straight linear line, and notice that we've got a gradient of 2. If I was to go across from, say, 2 to 4, then if I go across 2, then I'm going up 4. Okay, all right, still the gradient of 2. So we've now sketched a graph. Now it says the endpoints from 0, so we're going from 0 to 10. So if we actually wanted to, we could do a bit of substitution here, and we could say that when n equals 10, let's go ahead and substitute it into C. C is equal to 2 times 10, let's use brackets, and then plus 10 now. That's going to be 20, that's going to be 30. So if I went all the way over to here, let's say to 10, then, and if I sort of extended that across, that's not very straight, is it? Let's go up to here. Then it's actually going to get to this point here. I'll put a little closed circle, which means we're sort of including that point, and that would have the coordinates. Well, n equals 10, c is equal to 30, 10 and 30. So that's sort of my end point there. Now it's saying use the rule to find the amount Sam earned after picking 9 apples. Well, if you could probably look at the graph, and if I went back 1, well, if I went back 1 and that was 9, you could probably guess that I'm going up. So go up by 1 in the N, I'm going up by 2 in the C. Okay, that's 28. Or we could do it by substitution. So we're looking at C, I. And so we can say that when N is equal to 9, always write this when we're substituting. What is C? Well, it's 2 times 9 plus 10, which is 18 plus 10, which is 28. But we didn't necessarily have to do that, because if we knew the concept of the gradient and how that affects these values, C, and how that relates to N, then we could do it sort of 2 ways. And likewise, we could find the number of kilograms Sam picked if she earned $57. Well, we could then say that when C is equal to 57, then we need to find what N is. And that's what we've been doing. We've been solving linear equations before this. So if I have 57, let's substitute that in. Well, we've got to find what N is. Okay, so of course we're adding 10 to both sides, so let's subtract 10 to get rid of that. We've got 47 is equal to 2n, and now let's divide both sides by 2, which gives us 23.5 is equal to n. So let's answer the question. Sam would have to pick 23, therefore it would be 23.5 kilograms of apples to earn $57. So really, look, just the same thing applied in worded sort of problems. Okay, now there's an example here that you can try later. I'll leave that. I'd like you to try it. We can go through in class a little bit later, but we do have to move on to finding the equation of a line. Now, if you get that whole concept of, y is equal to mx plus c, then we're going to have a pretty good time of being able to find the equation of those lines. Okay, sometimes we might be given the y-intercept and given a point on the line. So let's go ahead, and we're going to skip to page 22 now, and we're going to be finding the equation, the gradient of a line when joining the 2 points, because if we can find the gradient, we're going to be looking at finding that gradient, and then finally, if I'm given the y-intercept and a point on the line, we can also find the equation, and then there's one where we're given the 2 points. So, all right. Okay, so find the equation of a line. When we're going through step 1, we want to find the gradient, okay? Because, of course, y equals mx plus c. If I go ahead and find what the gradient is by using 2 points, then I know what m is. And then I can substitute any point we know on the line. We can find the y-intercept, and then we have all of the bits of information. We've got to find m, and we've got to find c. Okay, and then finally, substitute your values into m and c to solve for the equation. So that's just the general method for finding an equation of a line. Okay, so let's go ahead and look at one thing. But before we do, if you don't know the y-intercept, well, yes, we could still use find the gradient, and then we could substitute it into the equation. and then we can go and find what our C value is. Okay, so let's have a look at this. What is the equation of a line passing through the point 2 minus 5 with a gradient of 4? Well, let's first of all write out what we know. We've got y is equal to mx plus c, and we've been told that the gradient is 4. So what does that mean? It means that m is the gradient is 4. Let's go sub that in, and we've got this. Now, of course, we want to find what c is. So what does this say? Well, x comes before y in the alphabet. Here's my x and here's my y. So that means that when x equals 2, then y is equal to -5. Let's go and sub that in. And when we do that, then you can see there that we've got this 4 times, well, x is 2 plus c. Let's write that up. It's -5 is equal to 8 plus c. I want to find what c is, so let's subtract 8 from both sides. And then I do that, that's going to give me c is equal to -5 minus 8 is -13. So now we can say that the equation of the line y is equal to, well, we're told what the gradient is, 4x. 4x minus 13 is the equation of the line. The other trick to these is that there's not just one way to do it. This one way is we've been told what the gradient is, we sub the point in, we find what the y-intercept is. We haven't been told what the y-intercept is. So it's just knowing what to use when, because sometimes you could be given 2 points, like this example here. What if you don't know the y-intercept? Well, I'll get into this a little bit later, but this is basically just we have got 2 points, and let's look at the point on the left. First of all, let's draw this just to sort of get an idea of what it looks like. X and Y, -2 and 8. I'm just going to say is up here. Let's call that -2, 8. And that's going to be the point on the left, and what we'll tend to call the point on the left, we'll call that x1, we'll call that y1. That's sort of what's going on up here, okay? And it's one way of doing it, absolutely. This is going to be x2, y2, and that's 6, -4. So 6, -4. So we're going to sort of, if I try to keep this to scale, let's say that this is 6 and -4 might be down here. Okay, so 6, -4. Well, what could we do? If I trace the point between these lines, between these 2 points, you can see there that we're going to have a negative gradient, which you can see, hopefully, that the slope, we're going downhill like so. So it's going to be a negative gradient. And if we go ahead and, well, we're going to have to go, well, y is equal to mx plus c. Well, let's go ahead and find the gradient. Gradient is equal to rise over run. If you have your little triangle over here, hopefully you can see that the rise is this distance here. Okay, and of course that's the y part. If I go from 8 to -4 though, then that's going to be a distance of 12, isn't it? Okay, but technically the rise is, we'll call it -12 because it's going down. Okay, and then of course across, if I go from -2 to 6, then that means that would be a distance there of 8, wouldn't it? So -12 and 8. Now let's simplify that. We've got a fraction, or we could divide by 4, and we could divide by 4. Let's simplify fractions, and that's going to be minus 3 over 2. Okay, so now we've got y is equal to, we know what the gradient is, -3 over 2. X, it's a coefficient of x, plus c. Well, we don't know what the y-intercept is. We can sort of get an idea on where it is. It's up here, and it's going to be somewhere between 8 and -4, probably closer to 8 by the looks of things, but this isn't a perfect sketch. Well, how do we find that? Well, we can sub any one of those 2 points in. I'm just going to pick this one, okay? So when x is equal to 6, then y is equal to -4. And what we're going to do is we're going to do that to find c. Okay, so let's substitute these points. X is now 6. Y is now -4. Let's go and throw those in. -4 is equal to -3 on 2 times 6 plus c. All right. Hopefully we're getting better at multiplying these and making less mistakes. That's 18. -18 divided by 2 is -9. Okay, and now, of course, we've got to add 9 to both sides, which gives us c is equal to 5. So look, we've found our gradient. We've found our y-intercept c by substitution. It's really the only way we can do it. We'll go into a slightly another method later, but therefore our equation is y is equal to -3 on 2x plus c, which is 5. Okay, so that means that of sketching this graph, finding the equation, this y-intercept there is over here is 0, 5. All right, so look, definitely with these usually can be a bit tricky at first because sometimes knowing which method to use. But remember, you can always substitute, you can always go back to our equation. All right, so in summary, it can be challenging when trying to find an equation and deciding what method to use. Please write in your own words, your own summary, as well as the questions you have. Well, I think you really need to link it to y equals mx plus c. And what we've got to do is we've got to find the gradient, and that's sort of like the rise over the run. And if it helps, if you have 2 points, then you could find the rise. This is the rise and this is the run, and you could find it that way. Alternatively, if you found the gradient between two lines, you then can know a single point on the line, and we can find c. So often this is unless it's given to us, we can find this by using substitution. Now, you could write in English any words for your own summary, but I think it's really important for you to write out, in English, what it is, and how you would go, what method you would use to solve these. Okay, now, just quickly, the equation of a straight line, if we like, is we're over here, down here, we've got this sort of equation here. Just note that that is just a rearranging. If I rearrange and I get, if you have a look, let's go, just keep that in mind. And over here, we've got, let's have a look. We've got over here, what is the rise? Well, the rise is if I subtract y1 from y2. Okay, so you see there, y2 subtract y1 is going to be that distance there. And if I have x2 and then I take away x1, that's going to be my run. Okay, so if I go ahead and, so what we can say is that m is y2 minus y1 over, this is the same really as rise over run. It looks confusing, but really all it is a difference of the two coordinates, all right? We're looking at this distance here for the rise, which is y2 take y1, as you can see that's there, and x2 take x1 is here. And as you can see, if I rearrange that equation, we can sort of rearrange it to get this y minus y1 business. Okay, so I will go through this a little bit later, and I'll go through this with you in class for sure and show you some examples of this. All right, now what I would like you to do is, I've been through a few examples. I'm going to get you to pause it now. Can I get you to try this if you can now? Do we have the y-intercept? No. So what we're going to have to do, find the gradient. Once you find the gradient, sub one of the points in to find what the y-intercept is going to be. All right, I'm going to pause this now. Give it a go if you can. If you can, fantastic. And I'll see you in a second. Okay, so let's talk about it. Once again, I think it's really helpful to write out what we're trying to find. We are trying to find this. Okay, number one, let's find the gradient. Okay, and let's do that. Let's do step one. We have got the gradient. Now, look, we can do rise over run, but why don't we try the old? Well, the rise is y2 minus y1, and I'm gonna talk at the point on the left. I'm going to call this x1, y1. The point on the right, we're going to call that x2, y2. Okay, so y2 minus y1. The good thing about this, the run is, by the way, x2 minus x1, is that we're going to make sure that we got the right sign. You notice that this is a negative line. Why? Because it's a gradient, it's a slope which is going down. And if I was to, y2 is 7, and 7 take 11 is what we have for that. If I now go ahead and let's rub that out, and you can see x2 take away x1, 6 take away 3. So 7 take 11 is -4, 6 take 3 is 3. So this has the gradient is -4 on 3. What does that mean? Well, the rise, it goes down 4, if you like, and then it then goes across 3. Okay, so that line, if I was to draw it in red or something, is going to, so a line is going to have that consistent gradient. If I was to go across 3, it's going to go down another 4 and be consistent for that. All right, now, step 1, we've found the gradient. Now, we've got to go ahead and we've got to find C. And we're going to find C by substitution. Doesn't matter which point you use. I'm going to use when x equals 6, y is equal to 7. In other words, I'm using this point here. And let's substitute. So, what are we substituting in? Well, we're substituting in this baby here. Okay, so let's, wherever there's a y, 7. Wherever there's an x, 6. And we know what the gradient is. It's -4/3. We just found that, didn't we? And plus c. Notice that there's only one unknown. We've got to find what that is, and that's c. 6 times -4. We're going to get better with fractions. That's -24. -24 on 3 plus c. Now remember, this is not all divided by 3. We're subtracting 24 over 3. So really, what's the opposite of subtracting 24 over 3 as a fraction? Yes, we want to add 24 over 3 to both sides. Now, I know that's more confusing because it's not a whole number, but if I have 7 plus 24 on 3, we can hopefully, let's bring this together. Let's bring this as a fraction. It's not going to always have any nice whole numbers anymore. If I wanted this over 3, then I'd have to multiply the top by 3. So that's 3 times 7 is 21. So that's going to be 21 over 3 plus 24 over 3, which, by the way, is 45 over 3. Look at that. We know that that is, well, probably, hopefully you realised that 24 over 3 is 8. But yes, 8 plus 7 is 15, or 45 divided by 3 is 15. Okay, so make sure, I guess the point I wanted to say is it's clearly like simplify as best you can. Okay, that's that 24 divided by 3, hopefully you can recognise is 8. Okay, so now let's take the equation. So therefore the equation of the line is y is equal to, step 1 we found the gradient, what was that, -4/3 x plus c, which is plus 15. Okay, so there you go, that goes through, and that 15 would tell us that the y-intercept is 15, isn't it? 0 and 15. All right, I know that that's a lot, and you need to absolutely practice. Now, we're going to have a bit of a work lesson, but we're going to go through and do our coursework online in our next class. Okay, look, I'm not going to go a whiteboard challenge problem. We don't have whiteboards, and I just want you to be able to grasp these skills, and I don't want this video to drag on forever. Again, we're also going to go through some worded problems, similar sort of concept, but what I would like to do is, if there's any time left, can I get you to please start the questions from 1G, and we're going to have all of next lesson to be working on these questions. Now, clearly, some of the ones we went through were sort of like looking at sort of in this area here. But hey, if you wanted to start at the beginning, that is fine. But just remember, we've been sort of focusing on ones which are sort of like these ones here. All right, I'm going to stop that there. I will see you in for our work lesson, next lesson. Thanks, everyone.